Okay, welcome to another video. Today I'm going to be solving one A-level math exam. This is June 2023, paper 1-2. Let's start solving. We'll be checking our answers as we go on. Um, the first question says the equation of a curve is such that dy by dx equals to 4 over x minus 3. Where x is greater than 3, the curve passes through the point 4, 5. Find the equation of the curve. So this is a question on integration. I am going to integrate this. To integrate, I have to bring this into the numerator, power minus 3. Then integrating gives me 4x power minus 3 minus 3 plus 1 divided by minus 2 into 1, differential of the bracket, plus c. So I have minus 2 over x minus 3 squared plus c. To find c, I use this point 5, and instead of x I'm going to use 4. So this gives me 5 equals to minus 2 plus c, c equals to 7. So the equation of my curve is y equals to minus 2 over x minus 3 whole square plus 7. That was an easy 3 marks. The next question says the coefficient of of x power 4 and the expansion of this is p, and the coefficient of x squared and the expansion of this is q. It is given that p plus q equals to 276. Find the least possible values of the constant a. So this is binomial expansion. I am targeting specific terms, so I'm going to say that I am going to the coefficient of x power 4. So I'm going to say that I'm taking out the terms NCR, a power n minus r, and b power r. So 6cr, x power 6 minus r, and a power r. I'm using this where my n is 6, a is x, and b is a. Okay, then I'm looking for x power 4, so I'm going to say that x power 6 minus r should equal x power 4. So I get 6 minus r equals to 4, r equals to 2. So 6c2 x power 6 minus 2, a power 2. So that gives me 6 into 5, 15, x power 4, a square. What is the coefficient? It's 15 a square x power 4. So that's the coefficient that I'm talking about. I'm going to highlight that so that I know what to use later on. Okay. Then the other bracket and the coefficient of x square is q. Okay. So again, the same formula. This time I'm going to say that 4cr ax power 4 minus r and 3 power r. Again, I have the powers. I'm going to say that x has the power 4 minus r. So x power 4 minus r should equal, I'm looking for the term in x square. So 4 minus r equals to square, r equals to 2 again. So 4c2 a power ax power 4 minus 2, 3 power 2. 4c2 gives me 6 into 9, 54 a square x square. Again, I'm looking for the coefficient, so I'm just going to use this one. So p plus q equals to 76. This was p according to the question, and this was q according to the question. I'm going to say that 15a square plus 54a square should equal to 76. 15 plus 54 gives me 69a square, and 276 divided by 69 gives me 4. So a should be plus and minus 2. Let's see if I have a condition. It says find the possible values. So both the possible values, then a is equals to both plus and minus 2. Okay, moving on to the next question now. This is express 4x squared minus 24x plus b in the form ax plus b whole square, where a, b, and c are integers to be given in terms of the constant p. So I'm going to again do my expansion do my comparison like I usually do for completing the square. Expanding this gives me these terms. Then I expand with a, and I say that 4 should equal a, and then minus 24 should equal to ab. So b is equals to minus 3, and then I have p, and I have ab squared plus c. So p equals to ab squared plus c. P equals to 4 into minus 3 squared plus c. So p minus 36 should equal c. So my expression becomes what? It becomes 4x minus 3 whole square plus p minus 36. Yeah, that is the correct answer. And it says hence or otherwise, so I can use the expression that I have. Let's write that down again. Plus p minus 36. Okay, find the set of values of p for which the equation has no real roots. Okay, I could use the original equation and do it, and I think that's going to be the easier bet. Because I will probably find it difficult to explain this to you, but I will certainly try. I can say that if I have this original equation and this has no real roots, then my b square minus 4ac should be equals to 0. Okay, a is 4, b is minus 24, and c is p. So b square minus 4ac uh, should be less than 0. Okay. I got a little confused with what I was putting. I wasn't getting a square, but I don't need to get a square. Okay, 576 minus 16p is less than 0. So 576 is less than 16p. I hope that's the correct answer. Yes, it says p is greater than 36. What I could have done is, you see, the objective of solving um, completing the square is to do this. So the idea of completing a square is basically if I put it equals to 0 and I ask you to find the roots, what you typically do is you take this to the other side and say that it's going to change the signs. Okay, say that I would then, sort of go on and take a root on both sides. But essentially, when I do that, if I want no real roots, then this should basically be less than 0, because for less than 0, I would have no possible roots and it would give me the same value as p is greater than 36, which is why this says that hence or otherwise. If I were to use this form, I would get this. But if you're used to doing the simple idea, you do the simple idea and it's perfectly fine. It says hence or otherwise. Okay. Then moving on to the next question, we have the right answer here. So moving on to the next question, this is a disguised quadratic equation. I can see that the powers are not in the form of the exact quadratic that I have, but they are essentially in that order where I could convert it into a quadratic by simply taking a substitution u equals to x cube. So the central term would become 215u. The last term doesn't even have an x, and this would actually become 8u squared, because when x cube is squared, it becomes x power 6. So I then have a quadratic. I can use the quadratic formula. I can say a is 8, b is 215, and c is minus 27. I don't need to break the middle term. I can just use the quadratic formula, minus b plus minus b square minus 4ac over 2a. Essentially, on the exam, you have to show me this as working. Otherwise, you don't get your marks because you have to show some amount of working before you can come up with a final answer. You can then use your calculators, of course. I can, sort of go onto my calculator. I can just show you on my screen. I can open up my calculator and say that, um, go to the quadratic part. Turn this on. This is not turned on. Okay. So I go to menu. I go to equation down there. That's equation. Then I go to polynomial. I select degree 2 and I input my ABC 8, 215 and minus 27. Okay, that way I avoid making an error. It's telling me that the best root is 1 over 8 and the other is minus 27. So I'm going to say that u is equals to 1 over 8 and u equals to minus 27. Those are my values for u, not for x, because my x was substituted. So I'm going to get that x back, replace it with u, and then take a cube root on both sides and say that x um, is equals to minus 3 and x equals to 1 over 2. Those are the two possible answers for this question. And I'm just checking the marking scheme, and that's right. So let's move on to the next question. The next question says that the diagram shows the curve this. The curve meets the x-axis at the points 0, 0 and 4, 0. Find the area of the shaded region. So this is again a question on integration where I'm trying to find the area. And first I'm going to write the expression that I want to integrate. I'm going to go from 0 to 4 and I'm going to integrate on the x-axis. I'm going to write dx in front of it because that's what I'm integrating. It's important to make sure that you write your expressions correctly. Then integrating the powers gives me 10x power half plus 1, which is 3 over 2. So I'm going to divide by 3 over 2 minus 5 over 2 x power 5 over 2. So divided by another 5 over 2. Okay. And then I have limits from 0 to 4. Now, at this point, you should understand that your marks are not about simplification here. Even if you were to simplify, they would essentially give me the same answer. What I will do is I will try to put everything on my calculator and get a final answer. Okay, this can go on my calculator as it is. I'm going to show you my calculator as well. Okay, it's easier to write this as 2.5 and this actually is 1.5 on my calculator as well. I'm going to do that on my calculator and then show you what the final answer looks like. For the lower limit, I can see that obviously when I plug in a 0, it's going to make all of those terms 0. So I don't think that's an issue. I think you can go on and write a 0 directly and it won't matter at all. 5 over 2. Okay, then showing you my calculator. Okay, so I'm going to type 10 into 4 power 1.5 over 1.5 minus 5 over 2 multiplied by 4 power, and this is also okay, so 4 power 5 over 2 divided by 5 over 2 or 2.5, whatever way you want to write, and that should give me my final answer, and that is 64 over 3. I don't need to show you any other calculations, and that's absolutely fine if you're doing that, and that should give you your final answer. That's a good 4 marks. Okay, so this question is about circular measure, and let's read through this question. This says the diagram shows the sector OAB of a circle with center O, angle AOB equals to theta radians and OP equals to x. So that the arc length AB is 2x theta cos theta. Now, when I'm reading this question, I should note the number of marks. My first thought is that if I want to calculate the arc length, I'll need OA, which means that I might just go on and apply the cosine rule. but I know that the cosine rule is a time-consuming process, and why would they ask me for 2 marks? So I noticed the triangle. This is an isosceles triangle, so this should also be theta. Then I know that when I split isosceles triangles, I would have this as 90 degrees. So let's call that something. Let's call that Q. Okay. So if I was able to somehow find OQ, I would be able to double it and say, I can find out OP. So I'm going to use cos theta equals to OQ over X. So X cos theta is OQ. So OA would be 2X cos theta. And that solves my problem. The arc length is R theta. So R is basically OA and theta is theta. So 2x cos theta theta. So 2x theta cos theta. What's the 2 marks? Then, okay, part 2 says area of shaded region. So I'm going to say that area of shaded is basically the area of the sector minus the area of the triangle. For the area of the sector, I'm going to say half. R was OA. So R square, that's 2x cos theta squared, and theta is theta. And for the triangle, I have half. The base is OA. That's what I've indicated here. So that's 2x cos theta. And then the height. Okay, so I've done a bit of calculation here and shown you that you can calculate the height by saying that sine theta equals to pq over x, and that should give you the height. So x sine theta, this 2 cancels out. I have 4x square cos square theta into theta over 2 minus x square sine theta cos theta. And this answers perfectly fine, but if you want to go on and take a common, you can do that. You can say that x square is common and cos theta is common, so that leaves me with 2 cos theta, 2 theta cos theta, and minus sine theta. Yeah, that is the final answer. Question number 7 says, by first expanding cos theta plus sine theta whole square, find the 3 solutions of the equation. So I'm going to say that in order to do this expansion, I will say that cos square theta plus 2 cos theta sine theta plus sine square theta, a square plus 2ab plus b square. So this and this add up to 1. I'm going to say that this becomes 2 cos theta sine theta equals to 1. So 2 cos theta sine theta equals to 0. 2 goes on the other side and gets done by that, and then I can say that either this equals to 0 or that equals to 0. No, now when I'm talking about 0, I'm talking about all 4 quadrants, quadrant 1, 2, 3, and 4. Let's see what the limit is. It's just the first and second quadrant, so I'm just going to keep it to the first and second quadrant. 0 is neutral, therefore you take all the quadrants, you do cos inverse of 0, and that gives you pi over 2. You say that quadrant 1 is pi over 2, and quadrant 2 is pi minus pi over 2, which is the same answer as the previous one. When you do cos sine inverse of 0, you get 0. So you go to quadrant 1 and you say the first answer is 0, and quadrant 2, the answer is 180 minus 0, which is pi minus 0. I'm going to say that that's pi. So the 3 answers are 0, pi, and pi over 2. Those are my 3 answers. And says hence verify that the only solutions of the equation this are 0 and half pi. Okay, so that looks like a question on just verification. So I could just, plug in the numbers and solve. I could say that cos I could just say that okay, this question is really about related to the hence. Okay, so it's, but I also have to prove to you that the third solution doesn't balance. So I'm going to first say try out 0 and say that cos 0 plus sine 0 equals to 1. Is that true? Yes, 1 plus 0 equals to 1. 1 equals to 1. Then let's also check cos pi plus sine pi equals to 1. Sine pi is 0. Okay, cos pi is minus 1. So minus 1 equals to 1, not possible. So therefore, pi is not a root. The only solutions are then pi over 2 and 0. So 0 plus 1 equals to 1, 1 equals to 1. So I verified that the two are solutions. Then it says prove the identity. Now I have to decide which side I want to start from. I think I am going to start with the left hand side and say that I'm going to first take an LCM, cos theta plus sine theta, into cos theta minus sine theta. The numerator gets multiplied with what I have here, and this gets multiplied with cos theta plus sine theta. Now this looks like a lot of calculations. What I'm going to do is I'm going to first write down the denominator. I can see that I have to simplify the denominator as well. So this becomes cos square theta minus sine square theta. I can see a square minus b square in the denominator. So sine theta cos theta minus sine square theta plus cos theta, 1 into cos theta, 1 into sine theta, and then minus cos square theta and minus cos theta sine theta. What that tells me is that some things are canceling out. Let's get rid of those first. And yeah, I see this and that. Both are with a negative sign. So let's arrange them and say that I can keep the negative outside, and this becomes sine square theta plus cos square theta. And in the denominator, I have cos square and sine square both. In the proof that I have, I just need sine square. So I'm going to replace cos square with 1 minus sine square theta. And in the numerator, I have cos theta plus sine theta minus 1. And I have 1 minus 2 sine square theta in the denominator. And that solves my problem. It says using the results, solve the equation this. Okay, so using the results, I can use this result and say that cos theta plus sine theta minus 1 or 1 minus 2 sine square theta should equal to cos theta plus sine theta minus 1. Okay, is this question related to the previous one? Yes, it is. Okay, and that's what I see emerging from here. I'm going to first say that I'm going to cross multiply this. 2 minus 4 sine square theta and cos theta plus sine theta minus 1. I'm going to move these to one side and say I'm going to move it to the right hand side. I'm going to move them to the right hand side and say that this is I'm going to put this in a bracket and move it so that I can quickly take out a common. So you see this bracket is common in both, so I can do that. I can say that 2 minus 4 sine square theta. Okay, let's take a common. Cos theta plus sine theta minus 1. So I'm left with the first bracket, and I'm left with, if this entire thing goes, I'm just left with minus 1. So either this equals to 0 or that equals to 0. That's 1 minus 4 sine square theta. Okay, if you notice, this is the same equation that you were asked in the previous part. So this had two solutions for theta, which was 0 and pi over 2. I don't need to solve this again. I'm just going to solve this one. And then I get two possible values. Oh, I've run out of space. Relatively less space for a question that big. So I'm going to get sine theta equals to half and sine theta equals to minus half. to quadrant 1 and just quadrant 2 because the limits are 0 to 180. So alpha is sine inverse of half, which is pi over 6. So quadrant 1 is just pi over 6. And quadrant 2 is pi minus pi over 6, which is 5 pi over 6. So I have this answer, I have that answer, and I have these two answers. Let's check if these are correct. Yeah, those are all the correct answers that you have. Okay, just seeing if there was a simpler way of solving this. Okay, let's go to the next question. Next question is the graph of y equals to f of x, where the function f is defined by this. Okay, so I see a lot of transformations happening. On the graph, draw the sketch of y equals to f inverse of x. So I think that's easy. What you should do first is to draw your line y equals to x, even if it's not asked. Makes the question easier. So I'm going to draw this line y equals to x. Okay, this point is here. It's on the y-axis. It's going to appear on the x-axis here. Okay, at the same distance. I don't know what that coordinate is, but I know for sure that that is what I need to plot. I need to pick another set of coordinates that I can sort of decipher from here. Um, okay, or I can just say that, okay, I know that it's going up to 2 pi, right? And that's how it's going to go. It has to pass through this point. So that's the approximate curve that I have. Okay, I just reflected it, done nothing else. I think I have drawn it correctly. Yes, I have drawn it correctly. This was a little below pi and that's a little above pi. Although my curve seems a little more curving than the other curve, but that is fine. As long as it looks like a reflection. Okay, I know that this point always is there between the axis and that. If you were doing it otherwise, what I would suggest is, sort of figure out the coordinates of this first and say that this is 2 pi comma something. I don't know what that number is, but it's a little above 3 over 2 pi. So let's just write 3 over 2 pi and we're going to plot it a little above that. So I go on and plot y coordinate as 2 pi and a little above 3 pi over 2. So that's the point that I've plotted. Okay, so you can reflect individual points as well. Okay. Find an expression for f inverse. I think that's relatively simple. I can replace x over 4. So y minus 3 divided by 2 equals to sine x over 4. Sine inverse of y minus 3 over 2 equals to x over 4. For sine inverse x minus 3 over 2 equals to f inverse of x. I think that's simple then. Then this is the diagram shows above the part of the function g of x. So it's, I think, the same graph, but a little continued on the left hand side as right hand side as well. Okay. Complete the sketch of the graph of g of x on the diagram above and hence explain whether the function g has an inverse. So the graph is already plotted for 360 degrees. Okay. I 0 to 360. So I need to plot it for 0 to minus 360. And I know that a lot of transformations are happening. So as I've done in the class, I will plot this on my calculator and I'll just plot the negative side. So I know I am just going to say that I'm going to the table. I am not keeping this in radians. I've kept this in degrees. I'm going to type 3 plus 2 sine alpha x over 4 and leave g of x empty. I'm going to say that I want to start at minus 360 and end at 0. And my step is now basically it's x divided by 4, so every value is being multiplied by 4. So typically the step is 90. What I'm going to do is I'm going to make this a little different, and see, since I see a lot of this, I'm going to keep the step as 90 and see what happens. Okay, it's going to be easier for me to plot and come up with an answer. So on minus 360, it's at 1. Um, okay. Now, 1 would be, now, since the axis is a little tricky, let's improvise a little. Okay. Okay, so what I'm going to do is I'm going to label my vertical axis also in numbers, because it's difficult for me to figure it out. So this is about 1.57. That's 3.142 plus pi. That's 4.71. Okay, so let's just talk about those numbers. Okay, on 0 it is at about 3, which is true. Okay, that's about 3. Okay, on minus 90 it's at about 2.2346. So a little above 1.57, and I would say that this is about here, 2.2346. Let me check if that's exactly halfway. Okay, yeah, and that looks exactly halfway. So I'm going to say that um, here, and then on minus 180, I am at 1.58. That's about here. So this curve looks like it's going down like that. Okay, and it's going to end at about here. Okay, why? Because this graph also has to be symmetrical like the other graph, and that's why it's behaving in that way. So I've completed the diagram and hence explain why the yes, it is 1 to 1. Describe fully the sequence of three transformations which can be combined to transform the graph of y equals to sine x to the graph equals to. So I see a transformation in transformations in their order. I see a stretch, which is horizontal, factor 4. Remember that they are the reverse of what they are written as. Okay, followed by stretch vertical, factor 2. Stretch, okay, translate 3 units up, or with vector 0, 3. Okay, those are the answers. It's a good 6 marks, because every transformation has to be named properly and also described properly. Okay, question 9. The second term of a geometric progression is 16 and the sum to infinity is 100. So AR is 16 and A over 1 minus R is 100. Second term is AR, and that is 100 minus R. Find the two possible values of the first term. I think this is a question on um, just solving simultaneously. So 100 minus 100R into R equals to 16. So 100R minus 100R squared equals to 16. 100R squared minus 100R plus 16. I'm going to put that on a calculator and solve for R. 0.8 and 0.2. So what does that make my first term? My first term could be 100 minus 100 into 0.8. That gives me 20. And 100 minus 100 into 0.2. That gives me 80. Then it says show that the nth term of one of the two possible geometric progressions is equal to 4 power n minus 2 multiplied by the nth term of the other geometric progression. Okay, so the one geometric progression had the first term as 20 and r as 0.8, and the other term has the first term as 80 and r as 0.2. So term number n is arn minus 1. So I'm going to write 20.8 power n minus 1. And this one is going to be 80.2 power n minus 1. It says show that the nth term of one of the two possible geometric progressions is equals to 4 power n minus 2 multiplied by the nth term of the other geometric progression. So one term is definitely going to be larger than the other one. I can um, not really decipher from my calculations. So I'm going to say that let's take this first geometric progression and divide them by the second and see what we get. Do we get the multiple 4 power n minus 2? That's what the question is asking you. So I think if I want to get 4, I should divide the second one by the first one. That is going to give me a 4 right at the start. Okay, so this is 4. And then I'm going to say that this is 0.2 over 0.8 and the power comes out as common first. Okay, that gives me 1 over 4. So 1 over 4 is 4 power minus 1, and uh, okay, so I have 4 power 4 minus n plus 1. Okay, and I have then this 4 power 1 into 4 power 1 minus n. That gives me 4 1 plus 1 minus n. So 4 power 2 minus n. I got the reverse of what I was asking, so I think I should have divided the other way around. I should have done 20 over 80 into zero point 0.8 power n minus 1 over zero point 0.2 power n minus 1, and that should have given me the right powers. Okay, I can show that to you again. This becomes zero point 0.8 over zero point 0.2, the power comes out common, n minus 1. This becomes 4 power minus 1. 1 over 4 is 4 power minus 1. This gets divided and becomes 4. So 4 power n minus 1 gives you 4 power n minus 2. So basically the first term is bigger. The first progression was bigger, the second progression was smaller. Tough question at the end. Okay, let's look at this. The equation of a circle is this. The line y equals to half x is tangent to the circle at the point P. Show that one possible value of a is 4 and the other find the other possible value. Okay. Okay, when it says tangent, what clicks in my head is quadratics. So I'm going to try to solve it with quadratics. I'm going to replace um, y with half x plus 6 minus 3 whole square equals to 20. And then I'm going to say that this equation should have b square minus 4ac equals to 0 because tangent is b square minus 4ac equals to 0. So x square minus 2ax plus a square. Okay, this becomes half x plus 3. So half whole square plus 2 times half x times 3 plus 3 squared. Okay, equals to 20. So x squared minus 2ax plus a squared, x squared, a squared plus 1/4 x squared plus 3x plus 9 minus 20 equals to 0. I know that I need to take an LCM so that I can make it simpler for you. So 4x squared minus 2ax, 8ax plus 4a squared plus x squared plus 12x plus that's minus 11, so minus 44 equals to 0. So let's arrange this now. 5x squared plus 12x minus 8ax plus 4a square minus 44 equals to 0. So I have my ABC. B square minus 4ac should be equals to 0. My B is 12 minus 8a whole square. A is 5 and C is 4a square minus 44. So that should equal 0. 144 minus 24 into 8. The numbers have gotten tougher. 192a plus 64a squared plus minus 20 into 480 a squared, 20 into 4 880. Okay, so that gives me 64 minus 80 gives me minus 16a squared and minus 192a plus 880 plus 144. It's 1024. Okay, putting that into a quadratic again, minus 16 minus 192 and 1024. So I get a as 4 or minus 16. I think that was what the question was asking. So one of the values is 4. Other is minus 16. Let me check if those answers are correct. Yes, they are correct. Okay, for a equals to 4, find the equation of the normal to the curve to the circle at P. Okay, so I know the tangent to the circle has a gradient of half. So you do this in differentiation, that the normal should have a gradient of minus 2. If the value of a is 4, do I know the value of x and y? No, I don't. That is what I have to do in this question. I have to first solve them simultaneously again. I can pick up this equation and plug in the value of a because this is what I solved simultaneously, and that should help me solve the question further. So I've solved simultaneously again and ended up with this. I can replace this with 4. I don't think the coordinate of p is given. Yeah, it's not given, so I'll have to calculate. If you do that, so 5x squared minus 20x plus 20. Okay, going to again my quadratic 2 and 2. Okay, so x is 2. Y should be half x plus 4, half x plus 6. So y equals to half into 2 plus 6. 7. So those are the coordinates of P. The gradient is minus 2, so I'm going to say y minus y1 mx minus x1, y minus 7. Y minus 7 equals to minus 2x plus 4, y equals to minus 2x plus 11. Yeah, I think that's the right answer. Okay. For a equals to 4, find the equation of the two tangents to the circle which are parallel to the normal found in part B. Okay, for a equals to 4, find the equation of the two tangents to the circle which are parallel to the normal found in part B. So they must have gradients of minus 2. That is what I know so far. Okay, so there is some confusion. Let's try to draw this. In fact, I've drawn the circle. The first thing that I had was the center was now 4 comma 3 because I've given you a as 4. Okay, there was a tangent half x plus 6, which was tangent to the circle at P. And P was 2 comma 7. So 2 comma 7 should have been somewhere here. So the tangent must look something like this. What I've done so far is created a normal here, and the normal is definitely passing through the center because it's creating a 90-degree. Now what I wanted to find in this question is to find equation of two tangents that are parallel to this normal. Okay, So I need to find the equation of these two lines that I've just drawn. What I know is that if this line had a gradient of half, this line has a gradient of -2. This should also have a gradient of -2, and this should also have a gradient of -2. But in order to construct the equation of this and that line, I need these 2 points. Now, what clicks here is that I could have this equation. Okay, this equation will also have a gradient of half, and it's passing through the point 4, 3. Can I construct the equation of this line? Can I say that y minus 3 equals to half x minus 4? So 2y minus 6 equals to x minus 4, 2y equals to x plus 2. What I can do with this equation is I can go ahead and solve this simultaneously with the equation of the circle that I have. What will that tell me? That will tell me the points at which these lines are intersecting. Okay, if I've written the correct equation of the circle, yes. So I'm going to solve simultaneous and say that the substitution is 2y minus 2 from here. 2y minus 2 equals to x. Okay, so 2y minus 6 whole square, y square minus 6y plus 9 equals to 20. 4y square minus 24y plus 36 plus y square minus 6y plus 9 equals to 20. 5y square minus 30y plus 25 equals to 0. I don't even have space. So what are the two possible values of y? 5 and 1. What are the two possible values of x? 0. So 8 comma 5 and 1 comma 0. I have the gradient of the lines that I want to create, so I'm going to first put in the first one, y minus 8 minus 2 times x minus 0, and sorry, x minus 5, and y minus 8 equals to minus 2 times x minus 0. Okay, and that should give me my final answer. Y equals to minus 2x, that's plus 10 plus 8, so plus 18. Yeah. Okay, I've written these coordinates the other way around. Yeah, that's the mistake that I've made. So 16 plus 5 is 21 minus 2x. Y equals to minus 2x plus 8. Okay, that is for this question. Let's look at the last one. It says where k is a positive constant, the equation of the circle is this. Find dy by dx. So I'm going to go with y equals to k for x plus 1 power half minus x plus 5. So dy by dx is k over 2 half k for x plus 1 half minus 1 into 4 minus 1 plus 0 2. So that gives me 2k for x plus 1 power minus half minus 1. Yeah, so that's dy by dx. It says find the x coordinate of the stationary point. So I'm going to equate that to 0 and say that 1 on the other side, 2k over 4x plus 1 power half, cross multiply, square both sides, so 4x equals to 4k square minus 1 That should be it. Let's check if we have the right answer. Yeah, we have the right answer. Given that k equals to 10.5, find the equation of the normal to the curve at the point where the tangent to the curve makes an angle of tan inverse of 2. Okay, with the positive x-axis. Okay, so given that k equals to 10.5, find the equation of the normal to the curve at the point where the tangent makes an angle of tan inverse of 2. So remember that uh, the uh, the angle between line and x-axis is tan inverse of m. So m is basically 2 for you. So this is gradient 2. So if the gradient of the tangent is 2, and so that's dy by dx. What you can do is you can take your dy by dx, which was 2k 4x plus 1 power minus half minus 1 and equate that to 2. K is also 10.5. So 3 equals to 21. 4x plus 1 power minus half. 21 over 4x plus 1 power half. 3 times 7, cross multiply. So 4x plus 1 equals to 49. 4x equals to 48. X equals to 12. So the value of x is 12. I want to find the equation of the normal. So the gradient of the normal will be minus half. I have the x coordinate. I don't have the y coordinate. Can we put that on a calculator and calculate from here? K is 10.5. Yeah. And 12 plus 1 minus 12 plus 5. Okay. So root of 49 into 10.5 minus 12 plus 5. It's me 66.5. Let me verify if that is the right coordinate that I'm going with. Yeah, 66.5. So y minus y1, m, x minus x1. I cross multiply 2y equals to 66.5 into 2 should give me 133 minus x plus 12. Okay, that ends the paper. I hope this was productive. Unusually difficult exam, but that is how things work. Therefore, the threshold was lower when students were actually doing this paper. Please make sure to like and subscribe and keep watching for more videos. Thank you.